Good evening, guys. Good evening, everyone. Welcome to FLM's System Designing Bootcamp session. So, before entering into the session, I have few questions from my end అనమాట. క్విక్గా ఒకసారి చాట్లో రిప్లై పెట్టేసేయండి ఓకేనా ఆర్ గైస్ యాక్టివ్ ఐ నీడ్ రెస్పాన్స్ ఇన్ చాట్ యూఆర్ రైట్ ఓ పర్ఫెక్ట్ సో ఐ జస్ట్ వాంట్ టు నో లైక్ విచ్ టైప్ ఆఫ్ ఆడియన్స్ వీ హ్యావ్ అంటే ఫ్రెషర్స్ ఉన్నారా ఎక్స్పీరియన్స్ వాళ్ళు ఉన్నారా ఎవరున్నారు ఒకసారి క్విక్‌గా మీ ఎక్స్‌పీరియన్స్ మీకు ఎందులో ఎక్స్‌పీరియన్స్ ఉందో కూడా పెట్టండి. అంటే ఇఫ్ యూ ఆర్ వర్కింగ్ ఇన్ నాన్ ఐటీ అని పెట్టండి. జావా మీద వర్క్ చేస్తుంటే జావా మీద పెట్టండి. ఆల్రెడీ మీరు ఎవరైనా సిస్టమ్ డిజైనింగ్‌లో వర్క్ చేస్తుంటే అది కూడా పెట్టండి. ఓకే. ఓకే. కౌశిక్ 4 ఇన్ ఐటీ, జావా అండ్ పైథాన్ గ్రేట్. Shekshawali IT Java 4 years. Okay. Experienced Java plus. Okay. Fine. Sandeep Java 4 years. Student learning Java great sir. Still. Okay. Okay. Web designer. Okay. Experienced. రీసౌండ్ వస్తుందా? ఇస్ గైస్ లైక్ గైస్ ఫర్ ఎవ్రీవన్ అంటే నా end నుంచి రీసౌండ్ వస్తుందా? అందరికీ అలానే ఉందా? ఆర్ ఎల్స్ ఇట్ క్లియర్ రైట్? యాహ్! ఓకే. కౌశిక్ ఒక్కసారి క్విక్‌గా రీజాయిన్ అవ్వరా? మేబీ నెట్వర్క్ ఇష్యూ ఫ్రమ్ యువర్ ఎండ్ అనుకుంటా. ఒకసారి రీజాయిన్ అవ్వండి. ఆర్ ఎల్స్ యూ కెన్ యూజ్ యువర్ ఇయర్ ఫోన్స్ ఆర్ ఫైన్. ఓకే. ఐ గాట్ టు నో దట్ యాహ్! ఎక్స్‌పీరియన్స్ పీపుల్ ఉన్నారు. ఫైన్. ఓకే. సో మీకెవరికైనా సిస్టమ్ డిజైనింగ్ అంటే ఏంటో తెలుసా ఆల్రెడీ? అంటే డిడ్ యూ గైస్ ఎక్స్‌ప్లోర్ వాట్ ఈస్ సిస్టమ్ డిజైనింగ్ అని ఎవరైనా ఎక్స్‌ప్లోర్ చేసారా? ఐ నీడ్ క్విక్ రిప్లైస్ ఇన్ చాట్. సో సిస్టమ్ డిజైనింగ్ అంటే ఏంటి? ఎవరైనా ఎక్స్‌ప్లోర్ చేసారా? ఆర్ ఎల్స్ డు యూ హావ్ ఎనీ ఐడియా ఆన్ దట్? ఓకే. నో. ఓకే. ఫైన్. నో ప్రాబ్లమ్. సో, ఈరోజు సెషన్ ఏంటి అనంటే, అసలు సిస్టమ్ డిజైనింగ్ అంటే ఏంటి? అసలు మార్కెట్ ఎలా ఉంది? అసలు అందులో ఏం నేర్పిస్తారు? అసలు ఎవరు నేర్చుకోవచ్చు? విల్ బి హావింగ్ లాట్స్ ఆఫ్ డౌట్స్ కదా! అవన్నీ ఈ ఒక్క సెషన్‌లో విల్ బి గెట్టింగ్ ఎన్ ఐడియా. ఓకే. ప్లానింగ్ ఫర్ ప్రాజెక్ట్ ఇన్ హై లెవెల్ అండ్ లో లెవెల్. గ్రేట్ సంతోష్. యాహ్! సో, ఈరోజు సెషన్ అజెండా ఏంటనంటే దట్స్ ద థింగ్. సిస్టమ్ డిజైనింగ్ అంటే ఏంటి? అసలు ఎవరు నేర్చుకోవచ్చు? అందులో ఏముంటుంది? సో, దాని మీద మార్కెట్ ఎలా ఉంది? రియల్ టైమ్‌లో అసలు సిస్టమ్ డిజైనర్ అనే పర్సన్ ఏం వర్క్ చేస్తారు? ఏంటి అని చెప్పి ఈ థింగ్స్ అన్నీ యూ విల్ బి గెట్టింగ్ టు నో. ఓకే. ఫైన్. ఆహ్, లేట్ చేయకుండా క్విక్‌లీ ఐయామ్ హ్యాండ్ ఓవరింగ్ ద సెషన్ టు ది ట్రైనర్. అండ్ వన్ ఆఫ్ ది మోస్ట్ ఇంపార్టెంట్ థింగ్ ఈజ్ ఏంటంటే, సో సెషన్ విల్ బి కంప్లీట్‌లీ ఇన్ ఇంగ్లీష్ అన్నమాట. సో, నో తెలుగు. సో, ట్రైనర్ ఈస్ ఫ్రమ్ లైక్ ఇంగ్లీష్ బ్యాక్‌గ్రౌండ్. సో, ఈ సెషన్ కంప్లీట్‌గా ఇంగ్లీష్‌లో ఉంటుంది. ఇస్ ఇట్ ఫైన్ ఫర్ యూ గైస్? ఇది ఓకే కదా అందరికి? ఐ నీడ్ ఆన్సర్స్ ఇన్ చాట్. ఓకే. పర్ఫెక్ట్. సో okay, no problem, right? Yeah. Session will be completely English. Okay. You have any doubts, guys? You can ask in Q&A and chat both as well. Most preferably, chat is fine. Q&A అయితే ఏం పెట్టకండి ఇప్పుడు. If you want to interact with the trainer or else if you want to ask any doubts, you can completely keep in chat. Okay. Here we have trainer Mainak. So he has 6+ years of IT experience. Okay. So yeah, over to you, Andy. You can carry on.
Yeah, thank you for that introduction. Can someone confirm if they can hear me in the chat? Okay, I see some thumbs up. So yeah, welcome everyone. As she already pointed out, I'll be speaking in English for the entire session. I'll try to keep the pace not too fast so that everyone is on the same page. And the aim of this discussion is to obviously talk a lot about system design. So yeah, let me share my screen. Let me know if the screen is visible. And let me place the chart in a place where I can easily see it. Give me a second. I think you guys can see the PPT, right? Please make sure to write things in the chat. I'm constantly noticing it using my second monitor. So it's not that I'm presenting, so I'm not looking at your chat. That won't be a problem. Can you guys see my screen? Okay, I see some thumbs up. Great. So let's go to the first slide. I'll be using my pen tablet for interacting with you guys. So yeah, should be fine. Just quickly testing my pen tablet. You guys can see this, right? I have just written my name and I think it should be visible. Yep, cool. You can see a PPT. You are not seeing the text that I'm writing on the screen. Can someone confirm whether you can see what visible? Yeah, thank you. So yeah, great. All right, let's begin with system design. As she already pointed out, the aim of the session would be to discuss system design. So for the first Uh, so the session is divided into three parts. The first part would be we'll just start with the basic. We'll cover this whole PPT where I'm just discussing the basic. We won't complicate it. We'll keep things to the minimum. I will complicate it once in a while just to go a little deeper. And then the plan would be to take a very simple scenario, or maybe not that simple. We'll try to look into how a payment gateway design looks like from a high level perspective. We won't be diving too deep into low level, but I would be discussing idempotency and few more important concepts that are regularly used in low level design as well. So without wasting much time, let's begin. So according to you, what is system design? Someone already said high level, low level, but if I were to tell you if I were to ask you what is system design, what would you say? Please write it in the chat. Any answer is fine. There are no wrong answers here. Anyone? I don't see anyone writing it in the chat. Giving overview of applications to stakeholders, etc. Okay. Only to stakeholders or someone else as well. All right. Let's try to think about it. Let's say till now you have created some applications. Most likely they won't be extremely big scale if you are working on your own. So chances are that you are trying to build a system. So let's get with a color. You're trying to build a system, right? And the whole point is, give me a second. The whole point is that we know how to write code, and even if we don't know how to write code, we know that chances are that if someone tells me to write a particular function which does something, we'll be able to write it. But when we are creating large scale application, it's not just about the code, it's about the design as well, like how each and every component to talk to each other and how we can make the system more and more resilient. Technical blueprint for a software application, that is somewhat correct. And in fact, not somewhat, it is absolutely correct that it is a technical blueprint that how are different components communicating with each other, right? So what do I mean by that? Think about this. Most likely you guys have heard about something known as the client and something known as the server, right? And mostly when we are getting into software development, you would have noticed these kinds of diagram that a client would send a request and the server would give back a response. How many of you have at least heard this much? I know that there are some people who are non-technical, but I'll try to keep it as simple as possible. API request, exactly. Right? So who is the client? You guys are the client. Let's say you are dealing with Amazon.com. Let's say you want to order something. So the buyer is the client and the server is Amazon, right? And from a very layman perspective, it feels like, okay, there is a lot of code written behind the Amazon website. All I need to do is send a request and I will get a response. As simple as that. But this is just code. But when you are dealing with system design, you have to consider a lot of things. Like what happens on a big billion day where I'm getting 100 million requests? Would the server or the machine where the code is running, would it be able to handle such a load? Right? What if there is just one item in the stock and two people are trying to buy that item at the same time? How do I decide which person gets it? All of those things, right? All of this comes under system design. If someone says buy now and he presses it twice, should the payment actually be deducted twice? I don't think so, right? So system design in general deals more with failure scenarios, like what happens if the load suddenly spikes, or what happens if our system goes down. Do we have some way to recover from these kinds of situation? How do we manage things in scale? So let's say the system was built for let's say 100K request, right? And suddenly on big billion days this 100K became 100 million, like request per hour or request per day. Is our system resilient enough to deal with such a spike in traffic, right? All of these things comes under system design. Guys, yes or no in the chat. Give me your thoughts. Is there anything else that you want to add to it? You mean server issues? I do mean server issues, but it's not just server issues. It's more than that as well. Server issues is part of this, but it deals with a lot more things. So what happens? I'll just take a quick scenario, but I'll discuss it further as well. Let's say you all guys already know that. Let's say you are dealing with Flipkart or Amazon, right? As soon as you let's say order something, right? As soon as you order something, how many of you guys have noticed the fact that you get a mail as well? Do you guys get a mail? Most likely you do, right? But think about it. Amazon is not responsible for mailing, right? Chances are that Amazon is communicating with Gmail to send out the mails. And now it could be the fact that Gmail has some restrictions, like I cannot process 100 mails per second, right? But most likely, think about it, there is a chance that Amazon is getting more than 1,000 or 1 lakh requests per second. So how are you getting mails even if Gmail has added this restriction that okay, I'll only deal with 100 mails per second? So chances are you cannot just keep the process in sync, right? Somehow there has to be a queue sort of a system where every time someone orders, things go in a queue, and slowly and gradually, basically with the rate of 100 mails per second, this queue is being accessed by some email consumer who's picking orders from this queue slowly and sending it to Gmail, right? That is why you might have noticed that you don't get an email instantly. Chances are your orders would be placed and eventually the system becomes consistent and you get a mail as well. How many of you have noticed something like this, sort of these things? Guys, yes or no in the chat, please. So it's just not about servers, it's about the whole system. Like in a lot of cases, you would want that the response comes instantly, right? But in a lot of cases, it can be the case, yes, like MQ systems, absolutely. Absolutely. We would use an MQ if we want to have some sort of a queue implementation. But I don't want to get ahead. I am just trying to paint a picture here. Like when I talk about system design, what am I actually talking about? Right? And mostly today we would be talking about high level design. So the discussion would be more towards the high level side, not the low level side. But yeah, I was about to say something, but then I forgot. Anyway, so okay, I remember now. So think about this. Let's say I'm just trying to give you a situation. How many of you know what is consistency? Like, does this word mean anything to you? Guys, uninterrupted services. That's not really correct. That's not really correct, Kaushik. Maintaining a constant flow of work. Not really. I mean, what you guys are saying might be true in some other context, but I am strictly talking about high level design. So there are two terms which are usually used. Actually, there are three, but I just want to talk about two right now and then introduce the third term. So consistency versus availability. I think what you guys are talking about is more towards availability, maintaining a constant flow of work, that the system is not down, uninterrupted services. All of that comes under availability. What do you think consistency means? This word. Guys, try it out. What do you think consistency could mean? What you guys are talking about is more on the availability side, that the website should be available. Handling pressure continuously, not really. No, that's not what I'm looking for, but I think you guys are going towards the right track. Acha, think about this. Think about this. Let's say you are watching Virat Kohli's post, Instagram post. Just think about the scenario, forget about consistency. Let's say on Instagram or Facebook, whatever, there is a very famous person and you're watching this guy's Insta post, right? Now think about this, millions of people are liking this post, right? So there would be a like counter. Can I say this? That the count of likes on a particular post. Can I say this? Can I say that this particular picture will have a number of likes on it? Do you guys agree till this point? Now think about it. At any point, if that count is wrong, do you really care? Like, do you really care if he has 1,000 likes or 1,001 likes? Would you really care? Tell me. Some people are saying nope, and which is correct. You really don't care if the count of likes is absolutely correct. Like if I'm liking it right now and you are not watching that count go up because of me, nobody cares, right? But you would care if you are not able to open Instagram at all, right? That would really bother you, that why am I not able to use this application? So basically, for Instagram or social media sort of a situation, you prefer availability, which is the fact that the application is available to you, more than the fact that the numbers or the data that you see on the application is consistent. Like absolutely true, right? Would you agree? Okay. Now think about the other scenario. Let's try to take another example. Let's talk about your bank account. Think about the fact that you have some money. Let's say you have some X amount, and when you are checking the balance, you are seeing Y amount, right? Would you like this? No, right? Because money is absolutely crucial. It could be that the bank is not available right now. You're not able to make payments, but you would never like the fact that okay, I have sent this guy money. It is not reflected on his bank account, and my money is deducted as well, right? So that is an example of a system which is inconsistent, where balances are not being shown correctly. System inconsistent, right? So the numbers are not correct, which is the worst situation, that you have sent someone money, it's not reflecting on their bank account, so that number is wrong and it is deducted from your bank account as well, which is even worse. But you would have been fine that okay, as long as my money is safe, I am fine even if I cannot check the balance right now, which happens quite a lot, that the bank is not available right now, you're not able to do transactions for the moment. Would you guys agree, disagree? It's more than what is WT? I have, it's more than WT I have, it's okay. Okay. But guys, quickly tell me, do you agree with what I'm saying? That in a banking application, consistency matters more than availability. Kaushik, which part do you want me to repeat? Basically, I'm saying there are two scenarios in a bank. One scenario is that your balances are reflected incorrectly. So balance is wrong. Like how much money do you have? And the other thing is that you are not able to access your bank, can't make payments, can't see balance. Let's take that one. Which one would you prefer more? I think you would prefer this more. That, okay, I'm not able to see the balance, but at least I know that the balance, whenever I see it, it would be correct. Do you agree with this? That you would like, if you had to choose between one of them, you would choose this rather than this, right? So banking application is a system where it is crucial that consistency matters more than availability. Do you guys agree, disagree? Right? So in general, when we are dealing with system design, it's more about how the system should behave rather than an absolute correct answers. You would see that the same situation might apply for some system, but it would not apply for some other system, right? There is a wrong expectation in systems design that, okay, I will just memorize all the system designs that there are, but that's not really correct, or rather, that's not the right way to approach it. It really depends on what do you expect from the system, right? From a social media system, I expect that, okay, the system should be available even if it is not consistent, because I know eventually it would get consistent. I might not see a post right now. Someone else might be able to see a post right now, but I know that in a while I'll be able to see that post as well. Do you guys agree? Any questions till now, guys? Please ask me. All right. So I think that should give you some idea as to what we are dealing with here. We want to make the system resilient. We want to make the system behave according to what is expected out of it, like support availability, support consistency, support partition tolerance, something that we would deal with in a while. But again, I was just trying to make you all guys come to the same part that what we are dealing with, at least in today's session. So let's get back to the PPT at least. So let's see what do we have here. So part one, system design fundamentals. So what is system design? The system design is a process of designing systems that can handle large scale. What do I mean by scale? Multiple requests or millions of requests. Today I might be getting 10 requests, so I can scale up my system that, okay, I will increase the CPU power, I'll increase the hardware to support, let's say, a million requests. But tomorrow I'm getting just 10 requests. So that's not ideal as well, right? That suddenly I have created a system which can handle millions of requests, but I'm only getting 10 requests. So it's not just about scaling the system up. You have to design the system in a way that it can also scale down. Think about the fact that you have a restaurant and you got 100 customers one day, so you hired 20 chefs. But from the following week, you started getting 2 or 3 customers every day. So those 20 chefs would become useless and you would waste too many resources paying them. Right? Similarly, things happen in system design as well. You cannot just create a highly available and highly consistent system in a situation where high availability or high consistency is not even needed. Right? So there is no one good answer. It really depends on what we are dealing with. So system design in general deals with handling, it is known as load balancing. Not really load balancing from a system design perspective, it's more about distributing load to multiple servers. We'll come to that. But what I was talking about is more about vertical or horizontal scaling. We'll come to that when we come to that. Yeah, auto scaling, exactly. That is still right to say. But anyway, let's not jump ahead. Right now, just talking about what scale means, remains reliable. What do I mean by that? What I mean by that is just because there was a spike in traffic does not mean that our system suddenly goes down, right? You would have noticed last year there was a Coldplay concert and Book My Show kept going down because suddenly the number of people trying to book the concert tickets were huge, right? And not only did they bring the system down, they were not able to book the tickets like which were in transit. Like, okay, I was about to book the ticket, but at the last moment the system crashed, right? So the system should remain reliable with heavy traffic as well, perform efficiently. It could be that your system is not going down, but at the same time, it's absolutely slow, low latency, high throughput. What do I mean by latency? It's the time in which my request receives a response, right? So if you think about it, you guys are all in a Zoom meeting, right? I am saying something, right? And you guys are hearing my voice. What does that mean? That the latency with the video playing is really, really low, right? Basically, latency is more about time, like how much time it takes for me to get my answer. The video that you're seeing or the audio that you're hearing, it has very low latency, right? Do you guys agree, disagree? Can you guys say something in the chat? Guys, any questions till now? Please ask me in the chat. It may be 1 second. Yeah, yeah, could be 1 second as well. To be honest, in video calls, it's not 1 second because guys are hearing me instantly when I'm talking to you. So it would definitely be lower than 1 second. But the point is not about 1 second. It's just about low latency. Guys, any thoughts on whatever I have said till now? Anyone, anything that I can answer? Okay, let's get ahead. Please continue. Okay. Perform efficiently. Again, okay, we were already on low latency. Like the system response time should be low. The system should should support low latency. What do I mean by high throughput? Anyone? What do we mean by throughput? Someone is writing consuming large data, right? We can get a bit more technical. So throughput from a system design perspective means that the number of requests the system can handle per unit time. So it's mostly about the speed at which the requests are getting handled. Does that make sense? So if you have a high throughput, that means the speed of the system is high, so the latency of the system would be low. Does that make any sense? Tell me, does that make sense? These are very related. Throughput is just the speed at which the requests are getting processed by the system, right? Okay. So let's take an example. If you have 100 users, chances are that you can have a very low scale system where you would need load balancing or maybe not. But in general, not a lot of servers are required to handle a system where you just have 100 users, right? But if you have a million users, then your life is really, really problematic because you really need to support a lot of scale, right? Those 1 million users can come at the same time in the worst case scenario, or in the best case scenario, they can be a bit sparse, like they're coming eventually per unit time. I'm not getting a lot of users, so that's still fine, right? So the system design should be exactly according to what is expected from the system and not, there is no one single best system design for a situation. It really depends on what you guys expect and how do you scale the system when the time is right. Okay, let's move on to the next slide. Why system design matters? I feel like at some point in some ways I've already answered this. Let's try to look into it. So the real world systems are distributed. What do we mean by that? Okay, let's try to understand this. Do I have something in the next slide? Not really. Let's try to understand this. What do we mean by distributed? Before that, would someone like to try? What do we mean by a distributed system? Would someone like to try? Sharding the work. I would appreciate if you guys uh, simplify your answers. One message can be listened by multiple instances or apps. Not really. I mean, maybe you are right, but what you are saying is more about pub-sub modeling instead of, yeah, exactly. You're talking more about Kafka or a pub-sub topic queue. That's not what a distributed system necessarily might be. You can have a distributed system without using a pub-sub queue or Kafka. If any heavy load is there, it will automatically be shift load to distributed systems. That is still somewhat correct. Yes, that is still not somewhat, quite correct. All right, let's try to understand this. Like, what do we mean by a distributed system? So, as I was saying earlier, let me change the pen color. Let's say that this is the client, right? And you have an application which is running on some server. So let's say this is a server and some application is running on this, right? Right now, life is good. Let's say you have at most 100 clients and your server is able to, serve all those requests very easily. Like the server capacity is not that great, but not that bad as well. So let's say it has two CPUs and some RAM. I don't care how much RAM. Uh, like these are the specifications of your server. By the way, for someone who does not know, server is just a machine. This laptop that you're looking at right now, the laptop on which I'm presenting this whole session, it is a server. Server is anything which has an IP address. We'll deep dive into that as well in today's session. So let's say this is the situation that you have a single machine where your application or your code is running, and these are the specs of your machine, right? And right now you don't have a lot of load on your machine. What do I mean by load? Like the number of requests that you are getting to this machine for which the server has to give responses, right? So right now, is this a distributed system? Is this a distributed system, guys? Pawan says no, Kaushik says no. Okay. Okay. So far, so good. All right. Let's say from 100, this loads gets to 1,000. What can we do? Let's say suddenly the load goes from 100 to 1,000. Scale up the server. Excellent answer. Excellent answer. I like the fact that you said scale up the server and did not instantly go for horizontal scaling, because the way I was presenting this, I was kind of uh, forcing you guys to say add multiple servers, but that's not the correct approach. Right now you have a machine and the load, to be very honest, has not increased a lot, right? Santosh, you are correct. I will come to that as well, but what you are saying is absolutely correct. Right now, focus on the fact that the load has gone up, but it has not gone up too much. So it is quite possible that instead of introducing new servers, what you can do is scale up the server. What do I mean by that? That okay, right now the capacity of the system is just two CPUs and 8 GB of RAMs. How about I go for eight CPUs and let's say 16 RAM? Don't focus on the numbers too much. Just notice the fact that I'm increasing the capacity of the system, right? And suddenly this server sort of gets a little bigger in capacity point of view, that okay, this server can now handle more load. What is the problem here? Can someone think about that? What is the problem here? Do you see any problems in whatever I have written? Tell me, like anything that comes to your mind. Based on load, every time manual scaling is required. That is very, very correct. You have raised an excellent point that, okay, but why is that a problem, Kaushik? Based on load, every time manual scaling is required. Why is that a problem? If I say that, okay, I'll manually scale it, what is the bottleneck? What's the problem in that? Although you are correct, and but I just want to tell everyone as well, like, what is the problem? We cannot expect the we cannot expect the load. Let's say we were able to expect the load then. What happens then? Let's say I am able to expect the load. Basically, the point I'm trying to get to is every time you increase the specification of a system, like adding more RAM or more CPU, there would be a downtime with the machine. Like we would have to turn off the machine, increase its hardware capabilities, and then turn on the machine, right? That is the real issue. Although you are right, we don't know when the load comes. But even if we do know when the load is about to spike, the main problem is that there is a downtime. Because even if we don't know when the load comes, this answer is for you, Sandeep. AWS, which is a cloud service provider, can automatically increase or decrease the capacity of a system, like auto scaling. It's more about downtime with the machine, although AWS has solved that as well. But in general, there would be some downtime. And the second most important point is that there is you cannot scale a machine up to some extent. Like, okay, tomorrow from 8 GB, sorry, 8 CPU, I go to 16 CPU. Then I go to, let's say, 32 CPU. There is only so much I can do uh, for a particular machine, right? At some point, it will become a supercomputer, which would be very difficult to manage. So, scaling up has a limit. Like, how much hardware can you add to a particular machine, right? Also, the third point is if you just have a single server which is serving all your requests, a single server which is highly capable, it has a lot of RAM and CPU, that single server is a single point of failure as well. That is a single point of failure. What do I mean by that? That if for any reason this server goes down, your application is gone. Do you guys agree with that or not? Guys, tell me. Say yes or no in the chat. Give me your inputs. Make this more interactive. Everyone agrees? But the main reason, even if it does not go down, although it will still be a single point of failure, like there is always a potential that something happens, some natural disaster happens to this, some fire caught up, whatever, I don't care. If this goes down, you are really, really screwed. But the main problem is just this, that you can add only so much hardware to a particular machine, right? By the way, what I just described to you is also known as vertical scaling, right? That I'm increasing the load, sorry, not the load, the capacity of a single server, right? This kind of scaling of a machine is known as vertical scaling. Is that okay? Does this make sense? But vertical is up to some extent, can't go beyond that, right? Exactly. That is what I have written here, no, Sandeep? That scaling up has a limit. That is exactly the point that you are mentioning as well. This thing. I'm not saying that do vertical scaling. I'm saying that there is an option to do vertical scaling, and these are the limitations of vertical scaling. Is that okay, Sandeep? Right? So what do we do now? The only other option that we have is that, okay, I had the client, right? And initially all his requests were going to this particular server, right? And this server cannot handle more than, like, let's say some load. So what I can do is I can introduce more servers. So before it could be that this was dealing with 10K requests. Right now, with the existence of multiple servers, the load can be balanced across these three servers. So chances are that this would uh, take 3K load, this would take almost 3K load, this would take almost 4K load, sort of something like this, like balancing the load. This way of increasing the server capacity by introducing more and more servers, right, is known as Sandeep rightly said, horizontal scaling. Does that make sense, guys? Does this make sense? Any questions on this? Or do you guys agree, disagree? Quickly tell me. Guys, yes or no? If you guys are not interactive, then I would feel like my voice is not audible and that creates a doubt in my head. So please, thumbs up, whatever you want to write in the chat, go for it. All right, cool. So, but there is a problem here as well. Let's say you introduce more servers. Earlier, the request was going to this particular server. Let's say, let me call this server X, right? Earlier, the requests were going to, no, okay, you guys are taking notes. Okay. I think this meeting is recorded. So I would rather expect you to focus on the meeting. But anyway, your choice. So anyway, let's say that this server, where when we had a single server, uh, back then all the requests were going to X. Like that's the name of the server. That's what I'm calling it, right? Let's say this was the server. Now I am saying, okay, I would introduce more servers, but then who would send the requests which are coming from clients to this and this server? Now also it can be the case that okay, all the requests are going to this server, right? Is that possible? Is that possible? So we don't want to introduce more servers and at the same time make the request go to the same server it was going to before. So there has to be some sort of orchestrator in between. So between the client and the server, so let's say this is the client. Earlier he was sending the request to the servers. Now, and let's say he was sending it to server 1, but now there is server 1, server 2, server 3, server 4, server 5, right? So basically what we should do is instead of the request going directly to a client, we should have an orchestrator in between which decides to which server should the request go to. And this orchestrator, as you guys are rightly pointing out, is known as the load balancer. Does this make sense, guys? Why is it called the load balancer? Because essentially, from a server's point of view, the request that the server is receiving is technically load for the server, right? And I don't want a server to be overwhelmed by load. So basically, what we have done is we have introduced a new server in between. By the way, this is also a server. This is just a server. These are all machines, right? We have introduced a new server in between whose sole responsibility is not to execute the application code or the website code, but to just delegate the requests to a server which can fulfill that request, right? So it could be that server 1 is dealing with 3K requests, server 2 is dealing with 4K requests. So it does not make sense for the load balancer to send the request, or forget the load balancer. It does not make sense that server 2 should handle one more request, whereas there are, like, at the same time, when server 1 is dealing with less request, and it could be the fact that server 3 is idle, it's not doing anything, it is serving no request. So it makes sense that the load balancer would redirect a request that it is receiving to either server 3 or server 1 instead of server 2, which is very, very busy right now. Does that make sense? Does this make sense, guys? Right? So don't get overwhelmed by the fact that, okay, what is this new load balancer thing? What the hell is this? This is just a server, right? Everything that I'm drawing in here is most likely a server, right? What do I mean by a server? It's just a machine. And what do I mean by a machine? Something which has an IP address. Does that make sense? Does this make sense, guys? Please tell me. Let's do something technical. I mean, it's not really technical, but I don't mind doing it. Let's try to, I'll try to tell you, although I have been a Windows user for quite some time. So it could be, wait. Okay, I have connected my tablet here. Let's see, can I open a new terminal? Okay, great. So let's say if I wanted to see Google's server IP address, what can I do? Can someone tell me? Most likely someone was writing that they are a web developer or 4 to 5 years of experience. I want to see Google's IP address. What can I do? Anyone? Basically, I can ping google.com. Do you see this thing here? Do you see this thing here? This is the IP address of a Google server. But I will let you guys decide something. Google will have many servers around the world, right? Like, what is special about this IP address? Like, what kind of a server is this? Can you guess that? Gateway. That's not what I'm looking for. Not really gateway. No. Load balancer. Exactly. Exactly correct. Exactly correct. The IP that I found out using the ping command, just give me a second, is Google's load balancer's IP, which we just saw, right? Because Google will have many servers. Why would it want to expose these servers' IP? Right? When I am communicating with Google, I am interacting with the load balancer who is delegating my requests to the right server. So when I'm pinging using my command prompt to find, okay, what is the IP address of google.com, I'm getting an IP address of a machine, which is actually the load balancer of google.com. Does that make sense? Guys, any questions till now? I hope whatever I'm saying makes sense to you. I will try to prove everything that I'm saying. It's not just I know that the topic is high level design, but I hope I am telling you things which are just not on the high level. We would prove everything that I'm saying, hopefully. Any questions till now, guys, or should I move on? Please say yes or no in the chat now. My yes, okay, great. All right, let's look at the PPT again. Okay, let me just close this. Okay, great. So we were at this slide at for some reason we started talking about uh, load balancer and everything. But that's great. We at least know what load balancer is. Let me just minimize this. Okay, why system design matters? Real world systems are distributed. Okay, that's why we were talking about it. That what is distributed system? Okay, let's get back. Okay, so what do I mean by a distributed system? The very fact that I have machines where there would be different machines solving different responsibilities. Load is distributed across different machine. There is not just one single server where things are happening, right? This kind of architecture is known as distributed architecture. Wait, why are things not reflected here? I'm not sure. Okay, let me see. I don't think this board is working. Just give me a second, guys. Give me a second. Display screen is paused. Why? Okay, let me just reconnect with my tablet. Okay, it's back. Yeah, so basically, it's above the page, sir. What is above the page? Never mind. Cool. So, this architecture where the whole resource that we have, the servers and everything is distributed, multiple servers might have the same data and they are serving the same responsibilities. This type of architecture is known as distributed architecture. That you had a single server earlier, you were increasing this capacity, but you were limited by the technology of your time that you can only scale up to such an extent. So what you are doing is you are introducing more and more of the same things. So chances are that okay, if this is some application code, the application code would be there on this server as well. It would be there on this server as well, and it would be there on this server as well. The three servers would have the same code, right? And the load balancer will delegate the request to one of these servers where the code is running, and this server would give the load balancer a response, and the load balancer will give the client a response. This kind of an architecture, right now I'm just talking about servers, but this kind of architecture where things are running on multiple machines just so that you can scale up when you want and you can scale down when you want, and things are available and consistent according to your needs. This kind of a architecture or system architecture is known as a distributed architecture. Does that make sense? Does this make sense, guys? All right, so let's go back to the slide. Give me a second. Yeah. So why system design matters? Because real world systems are mostly distributed because they have to handle scale. Failures are normal, not exceptions. Basically, what do we mean by that line is you cannot create a non-distributed system and expect that, okay, I have created a non-distributed system because I know failures would not happen, but that's not very realistic. You know for a fact that failures would happen. If Amazon thinks that, okay, I'll introduce big billion days where I will keep the prices very, very low, there is a very good chance that the amount of traffic that you receive on this website would be extremely high, right? When the sale starts. The chances are if they don't handle it, their servers would crash. There is a very real possibilities that people will order, but since the server crashed, those orders are not even recorded in the database, right? So again, handling loads and failures is a given. You cannot ignore that. Users, and you have to live up to certain standards as well. You cannot expect the user to not want fast responsive. You cannot expect the user to be okay with the fact that okay, your system is down, right? If you are an Instagram influencer, or even if you're not an Instagram influencer, but if you are an Instagram influencer, you would be extremely annoyed that it's your source of income and the application is not available. You're not able to post content or whatever, but it would not care that okay, this guy is not seeing the exact like count, because that guy knows that okay, I would be checking the like count tomorrow as well or in 1 hour as well. So as long as it is correct at some point, I don't care. I'm okay with the fact that the system will support eventual consistency, which is also a term, by the way. We'll look into that. Eventual consistency. Give me a second. Eventual consistency. Explains failures are common, not exception means. Explain failures are common and not exceptions. Okay. I mean, it's not a very complex line. When we say exceptions, we mean they cannot happen. Like in chemistry, you must have heard exceptions, right? Like in rare cases, something might happen, but it's extremely rare. So failures are not rare. It's possible that failures will keep on happening. So that is what this line means, that failures are very, very common and they are not rare. That is what this line means. Naveen, is that okay? Please say yes or no. Is anyone also confused about this line? That failures are normal, not exceptions. It simply means that failures will happen. You cannot treat it like, okay, they won't happen. It's extremely rare. You cannot treat it like that. Guys, say yes or no in the chat, please. All right. So an example is payment system. If money is deducted but not credited, that's a critical failure. So you have to handle that. There are multiple ways to handle that. Ideally, you should not let that happen. But if it does happen, the system should be smart enough to detect the fact that, okay, balances are not matching. Let me refund this amount. It happens, right? Like you are using an ATM machine, your money got deducted, but the money did not come out. In such a situation, most likely you reach out to a customer care person, but it also happens that, okay, your bank account is credited with that amount after a certain time. Does that make any sense, guys? Okay, thanks, Lokesh, for saying yes. So what do we have now? System design versus low level design. This is kind of incorrect. Both are system designs. Basically, what this slide wanted to say was low level design versus high level design. So in low level design, we are more interested in the code, like low level code, like how is a certain function running when I'm, clicking pay now, what is the exact code which is written and how is it working? Like, so the exact code and how to optimize that code, write it in a way that is very extendable or scalable, all of that comes under low level design, like writing the actual code, right? In today's session, we are mostly dealing with high level design, like what kind of APIs do I need? What are APIs to begin with? If you already don't know, what is a distributed system? Like what kind of architecture would we have? Scale is primary. What do I mean by scale is primary? It's the same thing that I've been saying again and again, that the system should be resilient to support huge traffic, right? I should be able to scale up the system or scale down the system based on my requirements. So an example is how user services scales to 1 million users. Suddenly, if I have some user service, although user service is not a good example, I'll again just take the Amazon example. Like suddenly, if I have a huge traffic spike, the system should be smart enough to handle that kind of spike and definitely not fail or crash, which happens quite a lot. I don't know if you guys remember, but a few days back, ChatGPT crashed like for almost 6 hours. Did someone experience that? Like it happened because of a cloud front issue, but it did happen like a few months back. But anyway, if you search for it, you'll get it. Like it was down for 6 hours in the evening. Okay, cool. Let's get ahead. What does system design include? API design, database selection, load balancing, caching, messaging queues, scaling strategy. I think we'll discuss all of this. How many of you can tell me? Okay, I should ask the reverse question. How many of you don't know what an API is? Just tell me honestly. Tell me very honestly, how many of you don't know what an API is? Because if you say so, then I'll explain it. Otherwise, I won't get into what an API is. Okay, no one is writing no. Although someone has written, okay, Kaushik says no. Okay, I'll just quickly talk about it, but I won't involve a lot of time. So for all of those who don't know, it's not that complicated. Imagine, okay, I'll just give you a very quick example. You guys know what an Uber is? Uber application, the taxi booking app. Everyone knows about this, right? Everyone knows what Google Maps is, right? Think about the fact that in Uber application, you see Google Maps. Can I say that? Can I say that? Right? How does that happen? Uber is communicating with Google, right? And asking for a Google map of a particular location. What the hell? Uber is talking to Google Maps and asking for the map of a particular location, and Google Map responds with a response like, okay, here is the map. This is how the map looks like for this location, and that is what is rendered here, right? So how does Uber communicate with Google? Think about that. It communicates by something known as an API. You can just assume that API is a URL for the time being if you already don't know, right? Uber calls Google's API or some link provided by Google, and if Uber is calling it, it will get a response, and that is displayed here. In very layman terms, again, I'm oversimplifying this, I know. If there are two softwares, and let's say one software wants something from the other software, then what happens is software 1 calls the API of software 2, right? In this case, software 1 becomes the client and software 2 becomes the server. Does this make sense? So let's say if you're doing some payments using PhonePe or Google Pay, you're calling Google Pay's API internally, and Google Pay would be calling some banking applications API to deduct money or whatever. Does that make sense? Does that make sense? Guys, say yes or no, right? But why did I suddenly talk about it? Because we are the ones creating this system. We are not creating clients. There is a client and a server in an application. We are someone who's designing an application. So we are designing this part, right? And if we are designing this part, how would other people communicate with this part? Using this guy's APIs. So that is why this slide says that when we are doing high level design, we have to think about what will the client call me for. Like if I'm designing Amazon system design, I know that the client will call me to view the inventory, like what all is there. It will call me for the price of a product. It will call me for booking an order for a particular product. It will call me for adding something for a cart, right? So for all these use cases for which the client will call me, I need to have APIs, right? Or links. And the API, so the API design is part of the link that would be exposed to the client. Okay, someone can call me using this API, someone can call me using this API, so on and so forth. Does that make sense? Right? Then database selection. What kind of database would you select for your application? For banking application, you want to select a database which is extremely consistent. But for social media, you want to select a database which might be less consistent but more towards the availability part, right? We'll discuss what these databases are. Load balancing, I've already talked about. Caching is just storing responses. We'll get into caching as well, don't worry. Message queues. We'll talk about this, or we can talk about this. But I would like to talk about all of these things when we are doing the system design of API gateway. There it would make more sense. Scaling strategy. So the only scaling strategy that we have discussed so far is the horizontal scaling strategy. Make sense, guys? There are multiple scaling strategy. This message queues things that you are looking at here is also a scaling strategy. Like how do I scale the system using queues? We'll get into that. Real world constraints, again, it is talking about the same thing. Yeah. So high traffic, what happens if my system goes down? What happens if there is a network delay? What if the data is not consistent? In banking case, you cannot afford data inconsistency, but in social media case, you can afford data inconsistency, stuff like that. What is concurrency? Would someone like to try? What is concurrency? Would someone like to try? What do you mean by concurrency? I mean, there's already an example given. Multitask. Not really. Multitask would mean that the same person is doing multiple tasks. That is not where we want to include concurrency. Same seat in bus booking. Yeah. So basically, what I mean by that is, let's say there are two people, right? And then there is a movie theater or some sort of a booking app, right? And let's say there is a single seat. Let's call this seat 21, right? It could be that right now this seat is available because no one has booked it, and two people try to book this seat at the same time. So if the system is not built correctly, it could be the case that both these users get these seat. Like they would have an application, right, using which they are booking the seat. In both their application, they would see that their seat is seat 21, seat 21. Do you think this is a good thing? That both users, user 1 and user 2, are seeing that, okay, I have the book 20, I have the seat 21. No, right? This is extremely weird because at some point they will come to claim that seat, and then there would be a confusion like, okay, why are both people getting the same seat? Do you guys agree, disagree? So this is what we mean by handling concurrency issues. Like two things, if they're happening at the same time, should not mean that the system goes inconsistent, right? This is an example of inconsistency, right? So most likely booking systems have to be consistent, right? Because one there should be a one-to-one relation between a seat and a person. You cannot break this consistency, you cannot break this rule. So the system has to be consistent. In such a situation, like there are multiple ways to dealing with this. The most common and obvious way is when one person even tries to like let's say press book, he will see whether the seat is available and then he'll try to book it. This whole process of reading, like if the seat is available and then writing the fact that I'll be the owner of the seat, this process can be one unit of work, and until since it has started and until it has ended, the seat can be logged. So in between, if anyone else tries to see, even if anyone else tries to book this seat, he will see that it is available because this whole thing has not happened yet, but he would not be able to book it because there's already a lock on this seat from an application point of view. If one person is even looking at the seat, because you will see something like this in airplanes, if you have even pressed book a seat, it will assign you a seat for now, and till your whole process is complete, no one else will be able to book that seat. But this will have a time window of 10 minutes as well. You cannot do this like, okay, you are looking at the seat and you have never booked it. What that then what would happen is then the seat would always be locked and no one even buys it. So there is a timer associated with these things as well. Yeah, in Book My Show, this happens as well. That there is a 10-minute timer. You start the booking for 10 minutes. No one else will be able to book that seat. After 10 minutes, if you have done the booking, great. You get the seat. If you have not done the booking, then your booking session expires and the seat that was locked for you becomes unlocked for someone else to acquire it. Does that make sense? Does this make sense, guys? Any questions till now? Again, there is no hard and fast answer. This is one way to deal with it. There are multiple ways to deal with it. Blocking always is not a good solution as well, but we are not going into that level of depth right now. So this is what I meant by concurrency, same seat, stuff like that. Handling concurrency, you can do it using logs, transactions, idempotency, keys, queues. I will discuss idempotency and queues during the system design. These two things are important. Maybe transactions could become a little heavy for this session, but I will try to give you a brief idea about what is idempotency and why do we need queues. Latency versus throughput. I think I already explained this. Latency is the time taken per request. Throughput is the number of requests that can be handled per second. So throughput is technically speed and latency is the time associated with that speed. As simple as that. So in a very ideal world, you would want high throughput and low latency. Scaling concepts, vertical scaling, horizontal scaling. I think I've already discussed this. System design mindset, you have to discuss trade-offs. Exactly. So what do I mean by trade-offs? Like if consistent, so okay, let me just try to discuss this because this is important. We are discussing what do we mean by trade-offs. So in a system, it is very unlikely that you get everything correct, right? So the kind of things that we have discussed right now is consistency, that is something that we want, and also availability, that is what we want. So think about it. The book my show example that we just discussed, can I say that this thing where two people are getting the same seat, this is a case of inconsistency because we want to maintain one-to-one mapping between a seat and a user? Can I say this? Can I say this, guys? Right? Also think about the fact that what did I say the solution was? That I will lock a seat for 10 minutes, right? That's what I said. Can I say that if a seat is locked for 10 minutes, then the system or that particular seat is unavailable to anyone else? Can I say this? Can I say this, guys? If I'm locking a seat for 10 minutes, that technically means that this seat is unavailable for the rest of the users. Can I say this? Tell me, guys, please. Yes. So can I say that in this book my show example, I am preferring consistency over availability? Can I say this? So technically what I mean by that is that I'm choosing a trade-off. Either I can go for consistency or I can go for availability. So the trade-off here is that I prefer consistency more, right? I prefer consistency more. So I will choose consistency at the cost of availability. That I know my availability would go down if I want to maintain consistency, and that is what we mean by trade-offs. That if I want something, something else will go down. In this case, availability went down. Does that make sense? Any questions till now, guys? Please ask me. So system design in general is all about trade-offs. When you are sitting in an interview, like most people learn system design because of interviews, although it's much more important because on an architectural level, you have to design those systems as well. But from a interview point of view, people grill you based on trade-offs, that which one will you choose and at the cost of what, right? So that's why the slide mentions trade-offs. Anyway, practical decision. So we just took the practical decision of choosing consistency for book my show. No solution is perfect because as you just saw, we preferred consistency at the cost of availability. So again, this is not a perfect system, but from a user point of view, it's acceptable. But the reverse is not acceptable, that seats are available, anyone is booking them, and when they finally want to sit at that seat, five people have the same seats. So consistency definitely matters more here. Do we have anything to reduce user waiting time for 10 minutes? In this case, he will choose another platform, then it kind of loss, right? So how do you design system there? That's a good question. So basically you're saying is, okay, wait, he will not go to any other system. I'm not saying that the entire system is down for 10 minutes. That's a confusion that you're having. I never said that book my show would be down for 10 minutes. That's not what I said. I said that a certain seat won't be available for 10 minutes. Now that's fine. If one seat is not available for 10 minutes, he will choose some other seat. Because that is what happens when you book as well, no? You will not get seats that you would like. I hope that makes sense, Sandeep. If let's say this is the seat you wanted, and you wanted corner seats for God knows what reason, and let's say you wanted two of them, they are not available. So you can't do anything about it. You have to book for some other seats. Are there any strategies available to reduce that too? I'm afraid not, because in the worst case, someone can potentially book these seats as well, right? So if they book it, then they would be marked as booked even before 10 minutes. You can reduce this time threshold time to 5 minutes if that's what you want. But in this system, since consistency matters more, you have to gamble availability in all scenarios. It might not be 10 minutes, it might be 5 minutes, but if let's say someone does book these seats, then those seats are anyway not available to you. So it's quite okay to show that okay, a certain seat is not available. In the worst case, they won't be available because someone is actually booking them. I hope that's okay. Can I move on, guys? All right. All right, let's start with the payment system design. Again, nothing too fancy. I just want to use whatever we have learned to sort of practice something. That's the whole aim here. So the aim is to sort of implement, again, this would not be a perfect solution, just saying that out loud. Payment system or gateway, whatever you want to call it, right? And we sort of want to do a system design on this. Like, let's see how this system looks like and what we can do, right? So, I don't think I would need the PPT for this. Just give me a second. What does the PPT have? Let me just quickly check it out. Problem statement, UPI, requirements, send money, receive money, view transactions. What do we want? We want consistency, high availability is not necessarily true. Low latency is correct. Idempotency, okay, database choice, challenges, trade-offs. Just give me a second, guys. Okay, yeah, I don't think I need the PPT now. I can just talk about payment system design on my own. All right, cool. So let's have a very open discussion. Again, no correct answers. In general, anything can be correct. But when we are doing system design, we need to first understand what is expected out of the system. So can I say that at least payments should be possible? Can I at least say this? Tell me. Think about it in this way. You are a buyer from Amazon, and Amazon is using your payment gateway. Think about in these terms, and you have to design this particular thing, right? You have to design this particular thing, payment gateway. So the payment gateway does not necessarily mean that this guy will be responsible for doing the actual payments, because that happens on the bank side, right? But how should the payment gateway look like? We'll try to use our existing experience and try to think about what all we can do in this limited time. So So in general, let me try to give you some context as to what happens behind payment gateways. So it is just a platform, right? Most likely Amazon won't have its own payment gateway. It will leverage someone else's payment gateway like Razorpay or whatever. Since most of you guys might have placed orders, please feel free to pitch in here, like in the chat, like what you have experienced, and if I'm saying something which does not make sense to you. It's just an open-ended discussion. So a payment gateway is just a platform that collect payment details from the users and secures them, tokenize the card details and everything, whatever with an orchestrator might be, and communicates whatever it has gathered from the user to a payment processor, which actually does something, right? So gateway is more like a traffic controller for payments, to be very honest. So in general, there are two components in here. One is the gateway itself, and the one is the processor, which actually does the payment, right? So let's try to think about what all do we need functionally. So as I've already mentioned, I should be able to make payments as a user, right? What then? Think about the fact that when we are actually doing payments, have you noticed the fact that we are redirected to some payment gateway application like Razorpay? Like from Amazon, there is a redirect that happens, right? And you are suddenly on Razorpay or JustPay where you are actually putting in your card details or whatever. Or maybe Amazon is sending your card details, but there is definitely a transition page that happens. How many guys have experienced it? Santosh is saying yes, redirects. The redirect definitely happens unless the platform has its own gateway. Can you explain like how it works, Razorpay? My question is it collect user info, then use some token, then at the end we have one API for all banks which will control it? Not necessarily, it's a multi-step process. We are discussing that only, so we'll break down the whole architecture, or at least my way of breaking the whole architecture. It could be that it's much more complex in reality, but we are just trying to do a system design, how you would do, let's say, in front of an interviewer, or let's say, if you wanted to do it, you would not have all the answers, but let's try to do it anyway. All right. So we know that there would be a temporary session created, right? What else? I would want to, do I need something else for now? Okay, I want to handle some problems as well. Let's say I have always talked about, or in this session we have talked about, failure should not happen. So I don't want, which is a very common problem, I don't want double payments to happen. Does this make sense? I don't want double payments to happen. If someone clicks pay twice, it should not be the case that the money is deducted twice. Does that make sense? Guys, does this make sense? Also, at the same time, let me think about it. There was one more scenario that I wanted to talk. Double payment should not happen, and there should be a way for retry mechanism. Sandeep is saying it should be idempotent. Absolutely. I want to discuss idempotency here. You're on the right track. There should be some way to retry something. Let's say at some point, I'll tell you why I want retry, because it can happen that the payment went through, right? But at some other stage, like on the banking side, something failed, right? So ideally, there should be some way to support a retry mechanism. This is where we would involve some sort of a queue or Kafka. Someone was mentioning that earlier. Is that okay? Guys, so far so good. Please say yes or no. Any questions that you want to ask? Just a thumbs up would do as well. So far, is the expectation clear? Like if I'm able to achieve all of this, I'm quite okay for the time being. And obviously, I want to support low latency. The system should be highly consistent because we are dealing with money, things like this. I'm fine. I want to support all of this. And these are the use cases that I want to discuss today. Is that okay? Am I even audible? Hello. Okay. Thank you for confirming. All right. Let's try to do it. I'll keep it extremely simple. So think about the fact that who all would definitely be there in your system. Always try to think about the core entities. Like I can give you an example. The chances are that when you are dealing with a Uber application, driver is an entity, user is an entity, cab is an entity. Uh, what else? Location can be an entity as well. May not be necessarily because this it keeps on changing. But try to think about the things that are usually fixed in your system, right? So in a payment gateway or in any payment application, the entities would be the clients, right? Let me use a different color. Client would be an entity, right? The person who's actually trying to place an order and making payments. Merchant is an entity. What do I mean by that? Like, let's say if I am on Amazon.com and I'm trying to do a payment from there. So I am the client and merchant is Amazon. Is that okay? Is that okay? You have to maintain the payments as well. So there would be some payments table. Since we are not designing Amazon, we are designing the payment gateway. We have to maintain the transactions as well. Exactly my point. Someone said cart and order. No, we are not designing Amazon, right? We are just designing the API gateway thing, which Amazon uses. So the gateway should not really care about the cart and the order, to be very honest. The gateway should just care about, okay, this person, this much money amount, this much money should be deducted. The other person or Amazon should get this much money. That's all the payment gateway should be concerned about. Cart and order would have been in our question if we were designing Amazon. We are not designing Amazon. Sandeep, I hope you're okay with that. Okay. So we would want to keep the transactions. What else? We would ideally want to keep the payment sessions as well. At least in my design, I would want to keep it. All right, let's try to do it. So let's try to draw a very basic diagram, like absolutely basic. So I have a client. What he will do is talk to the merchant, right? And the merchant would talk to the API gateway, right? And the API gateway would somehow talk to the bank, right? The bank would give a confirmation, and similarly, the API gateway will tell the merchant that what is the status of the payment, and the merchant can tell the client like what is the status of the payment. Does this make sense? Although this is a very rudimentary system design which I just did, but we are just starting with it. Can I say that on a very high level, this would be the flow, and we are more interested in this part? Can I say this? Can I make this transparent? Yeah, I can. Does this make sense, guys? This would be the overall flow. And I want to focus more on the API gateway part, but I'll try to say some things about these guys as well. Any questions till now? All right, cool. Let's try to do it. So obviously you would have multiple clients, right? And let's call these guys, like a lot of requests are coming in, and you would have merchants. So again, Amazon would have multiple servers. Let's at least draw two servers for the time being, but again, there would obviously be a lot more. And obviously you can place a load balancer in here, but I'm not going to be placing it because I don't care about it. I want to put a load balancer at least here, right? A load balancer is here. So Amazon would be sending the payment request to this load balancer. Why? Because eventually the thing that I'm building. Wait, why have I written API gateway? Sorry about this. I should not have written this. I actually wanted to write payment gateway. Payment gateway, right? And I want to design this. So it's the responsibility of the load balancer to delegate this request to these servers. So think about the fact that I want a highly available system, right? Oh, come on. Did I just erase everything? What? Just give me a second. Not sure what happened. Okay, there it is. Yeah, you guys can see it, right? I don't think so. Let me just check the connection. Terminal. It is paused. Okay, let it be paused. I will connect it again. Right. So basically what I'm saying is that I will have in this box, I will have multiple servers to support the payment gateway. That's why I have a load balancer in here. So let's say the load balancer is redistributing the traffic in here, right? What do you think will happen after this point? But why did we introduce a load balancer here? Because I want to make the payment gateway system more available, right? If I just had one server for payment gateway, it could be that if that server goes down, the entire thing goes down because it's a single point of failure. So I definitely need more servers to accept requests by this payment gateway. Obviously, the behind this, nobody knows like how many servers are there, right? When I ping google.com, I just got an IP. This load balancer sits in front of all of them so that load can be delegated. So I have multiple servers. What do I do after this point? What do I do after this point, guys? Acha, before that, just quickly tell me one thing. By introducing more servers, what am I achieving? What am I achieving by introducing more servers? High availability. Absolutely correct. This is the exact word that I was looking for. High availability. Okay. So far, so good. Now, what should happen? Based on our requirements. I think I wrote my requirements here. I hope they are not gone. Okay, so I said that the client will fill in its details, right? And the first time, what the server should do ideally is delegate this responsibility to a new server whose whose responsibility is payment intent. What do I mean by payment intent? That this server, like really listen to me what I'm saying. When you do a payment, what actually happens uh, is not a very sync process. You say that I want to do a payment. The server listens that okay, this guy wants to do a payment. Let me return him an ID. Let me return him an ID. Let me just draw it more clearly. Let's say this is the API gateway, right? The first time it receives a request, the request is delegated to a payment intent service. Don't get too complex by the word. All it means is that the payment will not happen right now. It will just store the request in a database, right? It will just store the request that, okay, I have received a payment request. We'll discuss what kind of a database this needs to be. it will store the request that, okay, this is what I'm receiving. Someone wants to do a payment. Let me return him an ID. Is that okay? Let me return him an ID. And what would happen with this ID? This ID, by the way, is unique. And this would be really useful. With this ID, a new session would be triggered, which is the redirect session. So for the redirect, a new service would be called something like a redirect service, right? And this returns you a new web page. So as I was talking about it earlier, this new web page would be something like a Razorpay web page. Right? You say something like I want to do a payment. What you would notice is that, okay, you have been redirected to some other gateway, which is most likely a Razorpay gateway. Does this make sense? And how do we identify, like, so basically there has to be some session, right? You might have noticed that, okay, you have to make the payment in 10 minutes or some 2 minutes. I don't know what the exact threshold is, but how many of you have seen something like this? Most of you might have seen it. So basically you are maintaining a session, right? A session for 10 minutes corresponding to this ID. So there is a unique ID to session relationship. Does this make sense? Does this make sense that, okay, there would be an ID corresponding to the payment someone wanted to do and a session associated with it? Most likely of some fixed intervals like 10 minutes. Does this make sense, guys? Just say yes or no. Guys, yes or no? All right. So what would happen in this session? Think about it. We would have an ID, right? We have 10 minutes of session, and the payment has to happen in these 10 minutes, right? Let's say the payment gateway, as I initially told you, the role of the gateway is not to make the payments. It will hand it over to some processor who actually makes the payments. So corresponding to this session, the API gateway uh, will put the payment or delegate the payment to some processor. Let me just write it down. Processor, right? Now really think about this. This is where the ID part comes into picture. Now this processor would talk to the bank about, like, let's do the payment. Is that okay? Now let's try to read our requirements. Our requirements were that double payment should not happen and there should be some way to retry everything. Okay. So let's say at this point, the API gateway sends the request for the payment, right, to the processor, and this part is abstracted from us. We don't know what is happening in this part because not part of our design. And let's say the processor is not responding for some reason, for any reason. So it could be that the API gateway tries again, right? And meanwhile, someone has written something. Yeah, I'm getting to it. So meanwhile, it could be the case that processor was actually working with the bank to get the payment done. But since the API gateway did not receive anything, it tried to do the payment again, right? And at this point, at some point, both the payments got successful and something like this happened, -100, -100. Do you think this is okay? Do you think this is okay, guys? Just because this guy did not respond in time or the first request was taking a lot of time, for some reason, this made a request again and two payments were deducted. Do you think that is acceptable? Tell me, guys, yes or no? Yes, that is acceptable. I don't think so. If you go for one payment and internally two payments happen, would you be okay? no multiple payments. It shouldn't happen, right? But right now it seems to be happening. So what do we do about it? What we should do about it is we have to design the database in a better way. So right now, or maybe not database, every time we are making the request or someone else is making the request to us, we only send the request to the processor if the ID has changed. So think about this. Uh, we had the API gateway, then we had the redirect session, right? So at the first time, let's say ID1 was created and the request would come here, and we have something like this, like for ID1, make the payment, right? And right now the status is pending, right? And redirect session would talk to the processor who is actually making the money move, right? If let's say I did not get a response, it could be that the API gateway tries again, right? But this time we already know that, okay, ID1 payment is status pending, so you should not go for another payment. So in this case, instead of doing the payment, just return the status that, okay, it is still in pending. The first time I did not have this record, so I did not get a status pending, right? That's why a record was created and things were delegated forward. If at the second or the third time I get the same request again, instead of actually making the payments, if the ID already exists, just return the status of that ID, that it is still pending. Does this make sense? Does this make sense, guys? Quickly tell me. Guys, yes or no? Hello. Right? No, we are not talking about circuit breakers right now, but you can relate it with that. But never mind. So two situations can happen. Or let's discuss the situation. What was the first situation? That the payment has never been achieved. So this ID record does not exist. So for first time, store record and make payment request. Request to processor. Right? This is the first scenario. Second, this is not happening for the first time. Let's say this is happening for the nth time. In this situation, you have multiple scenarios. You may think that, okay, I'll just return whatever is the status is. If the status is pending, I will return pending. If the status is done, I will return done. But think about the fact that the status, okay, let's just write it down. Status can be pending or done. In this case, always return the status. But think about the fact that what happens if status is failed. Like it could be that the processor sent back a failed status that, okay, I was not able to make the payment. In this special situation, you should actually try to make the payment that, okay, retry. Like exactly the same thing. Can I select it? Like this same thing should happen. I'm not sure what do we have here? Never mind. The same thing should happen here. Again, talk to uh, payment processor, right? Because the status is failed. So if I retry to do the payment, I know for a fact that payment can happen. Sandeep is asking transactional rollback. You can support rollback. Again, completely depends on your scenario. But I specifically said that for this system design, I want to support the retry mechanism. Where is it? I think I wrote it somewhere, right? I wanted to talk about the retry mechanism. So for idempotency, I want to allow the fact that if I'm getting a return status, try to retry for a couple of times. You don't want to retry it again and again, like up to some extent. Like try to rerun it 2 to 3 times. If it does not happen, then yes, sure, go for rollback. But if you really think about it, this answer is for you, Sandeep. Rollback would involve canceling the order as well, right? And canceling of the order should not be something that the API gateway does, or the payment gateway does. Sorry, I keep saying it API gateway. I'm so sorry. I mean the payment gateway. Canceling of the order should not be the responsibility of a payment gateway, right? Its responsibility is just money movement. Ultimately, if something fails, like at no point the payment was done, it can give the status like failed or whatever back to the merchant, which is Amazon in our case, and then it can decide whether to actually roll back the entire thing, like cancel the order, or maybe switch to cash on delivery. Like, okay, the payment did not go through. I will let the order stay, make it deliverable, and switch to a uh, cash on pay, cash on delivery sort of a situation, which happens in Swiggy as well. I don't think it happens in Amazon, but if let's say you're trying to place an order in Swiggy and the online payment does not go through, it does not roll back the whole thing. It would still place the order and switch to cash on delivery. But later you can place the order if you cancel the order if you really wanted to. Or also retry the payment as well. Yes. Again, retry of payment. I'm only talking about retrying of the payment since we are designing the payment gateway. If I was designing, like, let's say Amazon, I would not have talked about, retry of the payment. I would have just said if the payment failed because it's not my responsibility, I will just roll back the entire thing or put it on cash on delivery mode. So you really need to think about what you are designing. I'm not saying what you, Sandeep, said is wrong. Don't go for transactional rollback. But it's not the payment gateway's responsibility to roll back an order. It's the merchant's responsibility or Amazon's responsibility. So that part should not be part of your design. I hope that makes sense. Guys, does it make sense? Please quickly tell me. We can use compensation thing like status update using Saga for Kafka. So here it has to just update the status. Then again, we have to retry using some logic with that time frame. Let me think about it. There is a specific reason I did not want to involve Kafka at this point. Let me see. Or maybe we can involve Kafka, but just let me think for a second. How do you want to use Kafka here? Can you quickly talk about it? Usually, I don't want to keep payments async because if it has not happened for a certain time, I don't expect that I would put it in a queue and later someone else would pick it up. That is not I would have wanted for this design. But if your design allows it or your requirements allow it, you can put things in queue as well. Okay, let's discuss the queue. But I don't want to discuss it in this scenario. Let's say after the payment goes through. So let's say this is the merchant, right? He talked to the API gateway. Oh, come on. Again, I'm doing the same mistake. Payment gateway. Sorry. Payment gateway. The status is returned. I just want to talk about the queue thing. Now think about the fact that you want to receive emails as well, right? So one thing could be that you place the order and the payment happened through the payment gateway, and then you send the emails, right? This is what happens. Can I say this? Can I say this, guys? That usually this is how it looks to you, right? That through the merchant you did some payment and the email happens. Now think about the transactional rollback thing, like just a layman question. If the email sending is failed, should I roll back the whole thing, like, okay, roll back the payment, roll back the order? Do you think something like this should happen? This is for everyone. Like, let's say the payment happened successfully, but the email sending failed. Oh, if even if one thing fails, I will roll back the whole thing. Do you think it should happen like that? Sandeep and Kaushik are saying no. No, it should not happen like that, right? So this way of doing things, where actually everything is rolled back and one thing happens after the other, this is a sync process. But we don't want this. Nobody wants this, to be honest. Like in some situations you might want it, but in this situation we definitely don't want it. What we do want, however, is that let me think, that merchant talk to the payment gateway, right? And let's say it returned a status of positive, like okay, the payment went through. So what should the merchant do ideally is put the order status or some details of the order in a queue, right? So the queue would keep getting filled up. Notice the fact that there would be an email service here, right, which will pick things from this queue and talk to maybe Gmail to send out the emails. Does this make sense? Does this make sense? What is the benefit we are getting from it? The benefit we are getting from it is that the email sending of orders and the payment gateways, like payments, are completely decoupled now. The payment gateway can work, like payments will happen. It will just tell the merchant that okay, the payment has happened, and once the orders are marked as yes, they are successful orders, the merchant can put the order details in a queue, and a separate service can work on this queue, pick up one item from the queue, send out the mail, pick up another item from the queue, send out the mail. So even if email sending is failed for something, this part is not getting impacted, as Kaushik rightly pointed out, right? No, okay, no, you said something else. You said no failure of email service. Email service can fail. Let's say for this particular entry, the email service failed. Like it talked to Gmail, but Gmail was busy at that point, so it failed, which is completely fine. That does not mean that the payment gateway should be reversed. If some payload of a queue is, not working, like some item did not work, you can push it to some other queue, which is also known as a DL queue, dead letter queue. This will only hold all the jobs of a queue which failed. So later you can replay your email service on these items which failed earlier. And if you really think about it, you don't get the emails instantly. I mean, most likely you do get them because there are a lot of queues and a lot of workers. But even if it did not come instantly, the emails, nobody really cares that much because the website shows you that the order is placed, and eventually you know that the emails would come. So this type of a situation where you are not doing things in a synchronous manner, rather you are putting things in a queue and you're expecting that all right, once the items in the queue would be picked up, the job will be done. This is known as async process. And because of this, since there would be a delay because the workers would be working on the queue one by one, right? There could be multiple workers, but at some point the queue would be like full of jobs and they would be executed like one after the other. There would be some time before you get the expected result. So that is why this is an eventual consistent system. Does this make sense? That eventually you would get the mail. In this process, like the above process, this was not eventual consistent. The payment would happen, the emails would go, right? This is not eventual consistency. This is just consistency, right? But we don't want that level of consistency. We are fine with the fact that the payments are not rollback, and we are fine with the fact that eventually I know that the system would become consistent. I know that at some point, maybe not the exact second, but in 1 hour or 30 minutes, I will get the mail, so it's completely fine. I know for a fact that my order will take 3 to 5 business days, right? So as long as I'm getting the mail in, let's say, in the 24 hours, I'm completely fine with it. Although that does not happen because Amazon is extremely good. But from a human standpoint, eventual consistency is preferred more here. So again, it really depends on the scenario. Does this make sense, guys? Guys, does this make sense? Quickly tell me. Let's open the floor for questioning. I think we discussed quite a lot. We were able to discuss idempotency. Wait, which part was idempotency, by the way? Maybe I did not say it explicitly. Let me just try to say it out loud. Although some people I think got it. You remember the fact that we were doing this nonsense thing where we are maintaining this record, like for a particular payment, I'm checking what's the ID and what's the current status. If the status is pending, wait, let me think. Like if the status is pending or done, I always return the status whenever the payment is retried. If the payment is failed, I will try to retry the payment. But what's the basis of this? The basis of this was the ID, like this ID. This is the unique factor which is helping me decide whose status do I want to check, right? This right thing right here is the idempotency key. Like if I want to retry, I'll check what is happening with this key, which is unique to my process. If the key says failed, okay, then I will retry. But if the key says pending or done, I would not retry, even if I get another request. I hope that makes sense. Is that okay? Chalo, let's open the floor for questioning. At this point, you can ask me questions if you want. Like any questions, not just related to payment gateway. I hope the session was useful, but now the floor is open for your questions. You can use the chat. I'll answer them for some time. Let's do it. Duration of the course. Today was just a boot camp. So that is something that Harshita can talk to. You can talk to Harshita about it. Like whoever you talk to regarding this, they can answer these questions, like duration of the course. I'm just here to, uh, answer general doubts about system design as such. Please
Yeah,
ask me. Yeah.
uh, few things I will convey from my end.
Mhm.
Guys, how was the session firstly? How it was? Is it useful? And like it's most almost 2 hours, right? Did you gain some knowledge? What's it? Yeah, yeah, super. Thank you, Kaushik. Still, I need answers. Okay. Fine. So coming to course duration, when the course going to be launched, and what about the fees, placements, and everything. Soon we'll reveal. Okay. This is a boot camp. Just want to tell the you all like what about system engineering, sorry, system design and everything. Okay. Explanation was clear. Thanks, thanks, location. So guys, if you have any technical doubts, you can ask. Okay. You can ask in chat. If not, we'll wind up the session. If you don't have any technical doubts, you can keep it as no. FS, you can ask.
Mhm. I think I was able to explain most of the things that I wanted to. I think the initially we planned that we would take less time in the initial explanation, but I think that went on for a while. So I think whatever we wanted to discuss, we were able to discuss. But in general, if you guys have any doubts related to the session that we just had, you are free to ask them in the chat. And if you want to give me some feedback, I'm open to that as well, again in the chat. Yeah, I don't think I'm getting anything right now. So maybe we can wind up after all.
Yeah, I think so too. Okay. Fine,
Right.
guys. Thank you. Thanks for joining the session. Thanks for your time too, sir. Thank you so much.
Thank you.
For your patience and everything. Yeah.
No,
Thank
no,
you.
pleasure. Thank you, Kaushik. All right, I'll stop sharing my screen. Nice explanation. Thanks a lot, guys. All right. Thank you, Kaushik. All right then. Uh, I think you can end the meeting, Harshita, if you want.
Yeah. Thank you, guys. Thank you so much for joining. We'll meet you soon. Yeah. Lavanya, you
Thank
can
you,
end the
guys.
session.
Bye.